The last time we looked at this periodic table that indicated the charges of the metals, and I told you that if you are naming an ion and it has a charge, a single charge, such as let's say calcium here, then you just have to call it a calcium ion. But if it is a metal that does not have a clear-cut charge, you're going to have to communicate that with a Roman numeral. All right. Now we're going to move on to the anions. The anions are a little bit different. The anions get the ending IDE when they become charged. Okay, so chlorine, Cl, with 7 valence electrons, which when you add that one valence electron in becomes anionic, Cl minus 2. Chlorine turns into chloride, and we call it the chloride ion. Oxygen becomes the oxide ion. Nitride becomes nitrogen becomes the nitride ion. And it's important to note that is a D, because we also have ITE and ATE, and so there's a lot of confusion sometimes when I pronounce things. You know, do I say nitride or nitrite? I have this harsh German accent, so it's good to write these things down. It's very important because IDE indicates a single element. So sulfur sulfide IDE is a single element with a -2 charge, sulfide, whereas sulfate is something completely different. We'll talk about that in a second. And the charge is quite obvious. You should know this if you've been paying attention, but it boils down to having a charge of the group number -8. So chlorine is in group 7, and so group 7 minus 8 would be -1, but you should know that everything in group 7 just requires one more electron to be noble gas-like, so that's going to be a -1, and oxygen, which is in group 6, is 2 away from 8, so it's -2. It gains 2 electrons. All right. This is a nice periodic table that indicates the charges again, but also the negative charges this time. So every time you see a charge, that also implies ionic. So we haven't talked about covalent compounds and how to name them yet. We're just talking about ions. So keep that in mind, because there is a difference and it's important to distinguish. So metals that have charges are going to either be sodium ions by themselves or iron 3 ions. And anions are going to be nitride, phosphide, selenide, chloride, bromide, iodide, and so the charges are indicated here, -2, -1. Okay, and there are no Roman numerals for them. As you can see, the nonmetals always have one clear-cut charge. There are no different possibilities. It's just the metals that can have different charges, and they are the ones that get the Roman numeral. Okay, so now we're going to put it all together into an ionic compound. And before we do that, we have to look at polyatomic ions, right? So if an ionic compound is a metal, like sodium, that can combine with an anion, such as chloride, to form sodium chloride, that's the ionic compound, we can also have something called polyatomic ions. Now those are covalent compounds, meaning they are already something that contains more than one nonmetal. Here we have sulfur, a nonmetal, and oxygen, a nonmetal, and we have 4 of them. And when they combine, and I'll draw it, okay, we have a sulfur with, and you don't need to know that at this point, but we have a sulfur that has 4 oxygens around it. 2 of them are double bonded to oxygens, and 2 of them are single bonded to oxygens. And what happens is the oxygens are lacking, well, they have an extra electron, so they have a negative charge each on them. And so you have this overall charge on this compound. And so it's not done bonding, right? It's fine. It's helping itself by making these covalent bonds. So you've got covalent bonds between the atoms of a polyatomic ion. But because it has a charge, it can react with a metal to form sodium sulfate. So you can have sodium, and you'll need two of those combining with sulfate. So that's sodium sulfate. So polyatomic ions, there's quite a few of them. You would do well looking at the table, and I have it here in a couple of slides. On page 173, it has a summary of all the polyatomic ions that you should memorize. The only cationic one, the only one that will combine with another anion is going to be ammonium here, okay? So this is ammonium. And again, I want to point to you that these are covalent compounds that all have a charge. So if you see a covalent compound with a charge on it, it's going to be a polyatomic ion. And in all of these can form ionic compounds with other metals, okay? So this is cyanide. And I'm not going to write them all out. We have a table for that. That's hydroxide. Ammonium. And technically this is the ammonium ion and the cyanide ion and the hydroxide ion, and then we have the chromate and dichromate ions. And so those three are going to be super important to remember beyond this next test. They're going to come up in UChem 2, and you really would do well knowing some of them. Okay, let's talk about this one here. That's acetate. It comes from acetic acid, which is vinegar. And so sometimes you see it written as C2H3O2. Sometimes you see it written as CH3CO2, which is the structural formula, right? Remember, we had empirical formula, molecular formula, and structural formula. And so this is both the empirical as well as the molecular formula, but this gives you a little bit more insight on on the structure of it, okay? But either way, C2H3O2 minus, it's about that negative charge that makes it a polyatomic ion. So you can have sodium acetate. In fact, you're going to be making sodium acetate in one of the labs by taking vinegar and baking soda, which is sodium hydrogen carbonate. You combine the two to make sodium acetate. We have oxalate and manganate and thiosulfate, and then sulfite and sulfate. See, here we have S. Here's what we're having, what I was talking about, right? We have S minus 2, which is sulfite, IDE, single element. Here we have ITE, sulfite, and then here we have ATE, sulfate. Okay, and so we have this 8 and 8 again, right? Here we have the maximum number of oxygen, and one less than max is ITE. We see the same thing here for nitrate and nitrite, right? So this is nitrate. That's the maximum number of oxygens, and here we have nitrite. And then, of course, nitride, IDE, would just be N minus 3, a single element. Okay. So those that are on this table, which will come up here in a couple of slides, are the ones you want to know. All right, and then we have hydrogen sulfate. So we have sulfate here. We had a hydrogen. One of the charges drops, and you simply slap a hydrogen sulfate. Okay, and so you can have carbonate here and hydrogen carbonate, which is what I was telling you we are going to react with vinegar. Okay. Oh, here we are already. Oh, there's another slide after that with polyatomics, I think. Anyway, so this is the summary, the name, and you need to know the name, and you need to know the formula and recognize them so that you can then name things like Fe3C2H3O2, that you can be quick about it, that you don't have to go look for, oh, C2 H3O2 is acetate, and I know that acetate has a -1 charge, and so that's important that you know that. So here you go, acetate, -1 charge. If you can pull that out of your brain very quick, then you can name this very fast. And so I messed that up, of course, right? So we can either have this formula or we can have this formula here, right? So there are different possibilities. Why are there different possibilities? Well, iron can have different charges, and so this would be iron 2 acetate, and this is iron 3 acetate. That has nothing to do, this is a coincidence, has nothing to do with how many there are. It does in this case because this is -1, right? Now if we put this together with carbonate, FeCO3, then this would be iron 2 carbonate, right? Okay. So the Roman numeral indicates the charge, and you find out the charge by knowing the charge of the polyatomic ion and how many they are combined with, because 2 times -1 is -2, which means that iron has to be +2. Therefore, this is iron 2 acetate. So memorize these, make yourself bib cards, whatever it is. Be ready for the exam. Here's a few more. Okay, so remember with maximum and minimum we had chlorate here. This is chlorate, and this is chloride. Te, right? Remember chloride, IDE. It's just a single element, but then we have one more than max, so we call that perchlorate. So we simply put a per in front of the chlorate, and here we have one less, we call that hypochlorite. Hypochlorite, sodium hypochlorite is bleach, for example. And anyway, that's enough of the polyatomic ions. You get the idea. Let's dive right into the naming, right? So when we combine metals and nonmetals, we name it. We name the metal just to give it the name from the periodic table, right? If potassium ion is by itself, K plus, we say potassium ion. If it combines, we just call it potassium. Potassium. All right, with an M. And then the fluorine here, F, becomes fluoride. Fluoride, single M, potassium space fluoride. And you have to remember that everything we're naming right now is ionic. So we have a metal and a nonmetal, or a polyatomic ion. Here's a metal and a nonmetal making an ionic compound. Here is a polyatomic ion and a nonmetal making an ionic compound. And here is here's a metal and a polyatomic ion making an ionic compound. Okay? So metal, nonmetal, and then metal polyatomic ion. And so if you want, and so here we need to find out, it's really crystal clear, right? This is not a metal, and so you have to recognize that NH4 is a polyatomic ion. If you don't, you may get the name wrong. So NH4 is ammonium. So this is ammonium. You just give it the name of the polyatomic ion, space, and chlorine turns into chloride. Chloride. This is aluminum. And also consider if aluminum is going to have different kinds of charges, right? So find it on the periodic table and make sure that it doesn't get a Roman numeral, right? Potassium doesn't, it's in group 1, it's always going to have a +1. And but aluminum also is always +3, so we're safe here. So this is simply called aluminum, and this polyatomic ion is called sulfate. And if I gave you the name aluminum sulfate, you should be able to come up with a formula, right? So I might ask you to do this the other way around. And so then you need to know that aluminum is plus 3 and sulfate is minus 2. And in order to make a neutral overall compound, you need 2 aluminum ions and 3 sulfate ions. This is why we have Al2SO43, because 2 times plus 3 equals plus 6. And 3 times minus 2 equals minus 6. And so that all of the cations and anions added up together make a neutral compound. Okay, that's important. Iron is a transition metal. It's going to get a Roman numeral. So this is going to be iron, something Roman numeral oxide. And because you know that oxide is always -2, and these are in a 1-to-1 ratio, you know that iron is plus 2. Therefore, this is iron 2 oxide. Zinc is a transition metal that always is plus 2. So we just call this zinc. And who remembers what ClO2 is, right? That is chlorite. ClO is hypochlorite, and this is chloride, I-T-E. Let's practice a few more. Barium sulfate here, sulfide, I-E-D-E, barium. Barium, as the German would say. Sulfide. Sodium. NO3 has to be a polyatomic ion. Remember what it is? It's nitrate. Magnesium. Oh, what is HCO3? Go look it up real quick. No, I know what it is. It's hydrogen carbonate. Sometimes you will still see it as called bicarbonate, hydrogen carbonate. Here we have copper. Copper is a transition metal, so now we have to figure out what the Roman numeral is. This is chromate. We know we have 2 of these, and we have 1 of those, and so if we know the charge of that and we look it up, it has a -2 charge. And if this has a -2 charge, and there are 2 of these, this is +1. So this is copper, there should be an R here, 1, right? So this has a +1 charge. That's why we need 2 to produce an overall +2 charge to equalize this -2 charge from the chromate. Another transition metal that's going to need a Roman numeral. This is copper. This is cobalt. Copper is Cu, cobalt is Co. Cobalt. And this is 3 because hydroxide is -1. Hydroxide. Okay, let's wrap up the naming and then pause. Here we are going the other way around, okay? And then we're going to look into covalent compounds. All right, barium iodide. It's just about finding the metals on the periodic table. So barium is Ba. It's in group 1, so it's going to be a +1 charge. Iodide is iodine from group 7. So +1 and -1 there in a 1-to-1 ratio. Cesium is in group 1, Cs, and do this with the periodic table. Always have a periodic table. You can have a periodic table for the exam, so always have it available. Cesium and then sulfate is SO4. The charge on SO4 is -1. Sorry, it's -2. This is +1, therefore we need 2 cesium cations to do this. Okay, oxalate is not one of those that I have you know, but oxalate is C2O4 -2, and sodium is Na. So we need 2 of the sodium, Na2. I should switch that to like carbonate or something. Anyway, it won't hurt. Again, oxalate is not one of those that you are doing. Copper 2 means it's Cu with a +2 sign. Bromide is Br, which is -1, so we need 2. CuBr2. Iron 3 perchlorate, so we have Fe, and perchlorate is ClO4. It's got a negative charge, so what we do is we put parentheses around it because we need to have 3 of those perchlorates. Okay, and so the only way we can do that is by putting parentheses around the polyatomic ion and putting a 3 there. That means we have 3 perchlorate ions. Silver is Ag, silver is always +1, oxide is -2, it's Ag2O. Lead 2, hydrogen sulfate, so we have Pb, and then we have HSO4. HSO4 has a -1 charge. Lead has a +2 charge, so we need to put this into parentheses. And okay, so you're going to need to practice a little bit. I'm sure there's plenty in the homework. And I'm going to take a pause, and when we come back, I will start covalent compounds. Auf Wiedersehen.